Hey everybody, welcome to our office hour. So let's get started. Our tonight's topic is percentages, but let's work on our challenge problems first. So here we got a pretty challenging volume problem. And we're talking about the volume of a square pyramid. So the volume of a pyramid, if you look it up, is 1/3 length times width times height. But if the length and the width are the same, um, then we're going to call those the same variable. So like the length and the width, if they're both say x, then that's going to be x squared. So what I'm going to say is if we look at, I'll explain that more in a second. So it takes a rate of 11.5 gallons per minute, and it'll take 3.2 hours to fill. So if you were to do 11.5 gallons per minute, if you multiply that by 60, that's per hour, and then you multiply by 3.2, that's 2,208. So it's going to be 2,208 gallons is going to be the full volume. And I'm going to say that equals, so now here's the formula. 1/3 length times width. I'm going to call those both x. So it's x squared times the height. So this x represents the width or the length and width of the pool, or in this case, just the length of the pool. And then we've got h for height. Okay. So now after 1.6 hours, well, 1.6 hours is just half of this. So it's going to have a volume of 1,104, which is half of this. And that's going to be 1/3. Now it's going to have a different length. So I'm going to call that y, so y squared. And the height is going to be 2/3 of this total height. So 2/3 h. So these are the two equations that I get from this problem, right? So when it's half full versus when it's full. And then the ratio of the length of the water in the pool after 1.6 hours, so when it's half full, to the ratio of the length when it's full, that's just the ratio y over x. So essentially, my goal is to just figure out what y over the ratio of y over x is. And then that's going to be root k, and we want k. So we'll deal with that in a second. So if I want the ratio of y to x, I'm going to divide these equations, right? So I'm going to divide this way. So 1104 over 2208 is 1/2. All right. The reality is I didn't really need these numbers. If I were going to divide them, I would have had to have gotten half because the pool was half full. Um, and then when I divide 1/3 by 1/3, that goes away. Also, the h's go away. So then I'm going to have 2/3 y squared. That's this one divided by x squared. And then my goal is to just get y over x. So I'll multiply each side by 3/2. So I get 3/4 is y squared over x squared. And finally, I just need to take the square root of both sides. So now notice that this side would be the square root of y squared over x squared would be y over x. And y over x is what I'm looking for. That's the ratio of the length of the pool when it was half full to when it was full. And that's the square root of k. So k must just be whatever's under this square root. So k in our problem is 3/4. That's a really hard problem. Um, but again, if we're looking for the ratio of something to the other, then we're just going to manipulate the equations to get that. You could pick your own values in this problem and you'll still land at 3/4. But I just felt like this was the quickest way. All right, now on to number two. So, group of scientists. So, I'm going to do this problem as I read it. They're growing bacteria. They initially had 600 bacteria in a dish, and they measured that it grew 4%. We have to know that growing or increasing something by 4% is like multiplying by 1.04. And it does that every 2 hours and then after 4 hours. So that means if it did it every 2 hours, in 4 hours, it would have done it twice. and however many times it does it is the exponent. Um, they injected some agent to decrease the percent rate of increase. So 6 hours after injecting. So we changed the percent increase. So we changed the thing we're multiplying by from 1.04 to something else. So I'm going to call that X. And in 6 hours, again, this thing is increasing by some percent every 2 hours. Well, in a 6 hour period, there are three 2 hour periods. So that's three times it's going to get multiplied by some number. And in the end, there is 699. So this is the equation that I want to solve. All right. So what I can do is just multiply 600 by 1.04 squared and then divide 699 by that number. And I get x cubed is 1.07711. And then I want to cube root each side. And x is going to be 1.025. Now, this is important. We have to be able to work backwards. So we knew that a 4% increase gave us 1.04, right? That's because 4% leads to 0.04 as a decimal. And then we have to add that to 1 to show that we're increasing by 4%. So if we work backwards, we think like, okay, let's get rid of the 1 and then change it to percentage. We move the decimal this way twice. So that's 1.025 is really a 2.5% increase. So the increase is that one, 2.5. All right. So again, very, very difficult percentage increase slash exponential problem. Okay. So now let's really, really dive into percentages. All right. So that was a hard percentage problem that just happened to be one of our challenge problems. But now let's talk about percentages. All right. And what we have to be able to do is I alluded to it in that problem, but now let's really kind of like dive deep into how we would do that. So here in number one, Rita received 6% more bonus than the estimated bonus. All right. So there's two ways to increase something by 6%. The long way would be to find 6% of it and add it to the original. The shorter way would be to just imagine that the original is 100%. So increasing it by 6% is like multiplying it or figuring out what 106% of it is. So that's just 1.06. So whatever the bonus was, we would do 1.06D, and that is just answer choice A. So that's how we want to start looking at percentages, percent increase, percent decrease, is adding it or subtracting it from 100% first. So that's where we can look at number two. So after a 30% decrease, the new price of a shirt is $140. So what I want to do is say, okay, the original price is X. And what single value am I going to multiply X by to get $140? Well, a 30% decrease, if I start out at 100%, so if you do nothing, you're at 100%. If I take away 30%, now I have 70% remaining. So a 30% decrease means I'm keeping 70% of the original price. So 70%, that's 0.7 of X is going to equal 140. All right. So the key to this isn't solving this. We know we can do that. It's looking at it from this perspective. So back in number one, a 6% increase, we multiply by 1.06. Here, a 30% decrease, we multiply by 0.7 because that's 70% of. Then just solving this is pretty straightforward. Divide by 0.7 and you will get $200. All right, let's move on to number three. So the price of a dress is $24. The price is increased by 120%. So a lot of times we think we would use 1.2, but we will not. All right. So again, doing absolutely nothing is keeping 100% of it. And then if I increase it by 120%, that's really 220%. And 220% as a decimal is 2.2. All right. So what we're really multiplying by here is 2.2. So it's just 24 times 2.2, and that ends up being 52.8, really $52.80, but 52.8 would be fine to, that's how you would answer it. All right, so this is one where you could just find 120% of this, but then you'd have to remember to add it back. And instead of doing it in one step, you'd be doing it in two. But it's still, I would rather you be doing it this way for the harder problems or even some of the problems that we've done already. It's really important to look at percent increase and percent decrease in this way. All right, on to number four. All right, so the when they hibernate, their heart rate drops by 15 beats. This drop is 25% of its normal heart rate. Okay, this is super important. The reason I want to go over this is because this is not percent increase or decrease. It's 25% of its normal heart rate. So 25% of it is, whoops, not zero point 0.5, it is 0.25. So 0.25, so 25% of its normal heart rate is this 15. Right? So that's really important that it's not 25% less or 25% greater. That when it says of, that's when you actually use the percentage, and the of you could think of as multiplication. So now when we solve this, we divide by 0.25, and 15 divided by 0.25 is 60. All right. So it's really important that when it's percent increase or decrease, we kind of look at it the way that we've been talking about. But if they ever use the word of, then you just use the actual percentage that's there. So 25%, 0.25. All right. Number five. The number k is 80% less than the number m. So the way that I'm going to write that is like this. K is we should always think of as equals. Now, 80% less. This is what we're talking about. We are not going to use 80%. If something starts at 100% and it's 80% less, then that means it's 20% of. So that's 0.2m. All right. Now, and the number m is 120% greater. We've kind of already did this number. 120% greater, again, greater is when you add 100%. That's 220% of, which is 2.2 times 58. All right, so now we just kind of work backwards, and we've got 2.2 times 58 is 127.6. Now we throw that here, we multiply that by 0.2, and we get 25.52, which is C. All right, so when you see less or greater, you're not going to actually use that percentage in your equations. You're going to kind of adjust those. All right, now on to number six. A product's price is now 1.84 times its original price. By what percentage did the product's price increase from its original price? Now we're just working backwards. All right. So for instance, if we wanted to do a 25% increase, by now we should know that that's multiplied by 1.25. Well, now we got to work backwards. If it's 1.84 is what we're multiplying by, first we know it's an increase because it's bigger than one. And then we kind of just chop off the one and we say, well, we're increasing it by 0.84, which is really 0.84 is 84%. So 1.84 times something is an 84% increase on whatever it originally was. Okay. Moving on to number seven. So P% of X is 7. Which expression represents X in terms of P? This is one, if you wanted to choose your own values, you could do that, but I'm going to show you the more, I guess, mathematical way to do it. So this, first of all, is saying the word of, so we don't have to worry about using like a different percentage, like adding it or subtracting it from 100. But we need to think about mathematically what it means when we move the decimal. So if you were to get like, say, like 30%, you would know to use zero point 0.3. But what you're really doing is you are just moving the decimal, but mathematically you're dividing by 100. So p percent is really the number p over 100. So when you're using that either in a calculator or in an equation, you're dividing by 100. Now, of is multiplication, so times x is 7. This is the equation we start with, and then it's pretty straightforward. X in terms of p means I just want to get x by itself. So I'm going to multiply by 100 over p on each side. And that's really it. It's 7 times 100 over p. I mean, it's 700 over p, but the way they're given the answer here is c. All right. Now, if that's confusing, so again, the thing is when you're moving the decimal, just realize you're just either multiplying or dividing by 100. That's what moving the decimal is doing in these percent problems. And we just do it automatically, but in the one like this, you really have to like know that this is what you're doing with a variable. You can't write like 0.0p, like that just doesn't really make any sense. So, another way, if that's confusing, is just pick values. Just be like 50% of something is 7. Well, 50% of 14 is 7, right? And like we should know that. So that means we chose P to be 50 and 14 to be X. All right. And if it wants X in terms of P, then the answer that would give us 14 using P as 50 would be the answer. And C would be 100 times 7, which is 700, divided by 50. That does give you 14. All right. So like you can do it another way. If the mathematical way that we talked about is confusing at all. All right, let's move on to number 8. So the way again we have to. This one is hard is a little more annoying to choose values. So I really think like in the one before choosing values, I probably would have taken the same amount of time, but I'd rather you know the mathematical way as well for a problem like this where choosing values can really just get. I don't know. It's kind of like it's just a lot of extra work to do it that way. It's easier if you can simply just set this up the way we did the last one. So when you see h percent like this in an equation, just automatically know it's h over 100 times 12 is equal to 220%. So that's 220 over 100. And there's a reason that I did that of z, so times z. Now, I could have done 220% as 2.2, but what I like here is that since we've got to get z in terms of h, this 100, I can just cancel out on each side. And if I want z by itself, I'm going to divide each side by 220. So I'm going to have this 12 over 220 h equals z. And that's my answer. I just need to know what 12 over 220 is. But either you just throw that into Desmos or a calculator and let it reduce it for you, or you just divide each by 4 and you're going to get 3 over 55. All right. Another option is if you didn't think of doing this, you do h over 100 times 12. 220%, again, we should know is 2.2. And then you simply just divide. So you would do 12 divided by 100 is 0.12. You would do 0.12. Let me write that out. So this side, you'd probably do 12 divided by 100 is 0.12h equals 2.2z. Then to get z by itself, you divide by 2.2. So again, you get 0.12 divided by 2.2 is a decimal. But then if you either in the TI-84 you do like math enter, and it'll change it to 3 over 55 for you. So this is still just 3 over 55. Or again, you use Desmos. You put it into Desmos and then Desmos, you just click that button on the left side and it'll just change it to a fraction. All right, so a couple ways to go about this. And I also said you could pick your own values. You would do like, I don't know, but it'd be hard though. You have to pick a percentage here and then find what Z is and then plug it into all of them. I wouldn't suggest that. All right, number nine is this is a little bit different. I want to make sure that we know how to do a particular problem like this. So the way that we look at this is how many liters of 80% pure water? Okay. So if something is 80% pure water, it's 80% of it is water. So that's zero point 0.8 times whatever the amount is. All right, that's 80% of something is 0.8x. Must be added to 40 liters of 30% pure water. So that's 40 times 30%. So 40 times zero point 0.3 will produce 60%. So something zero point 0.6 times the amount. Well, here is the thing. Um, you know what? I probably should do this. I'm going to switch the order. Obviously, multiplication's commutative and it doesn't matter, but just to keep it consistent, I'm going to do the percentage first in all of them. So that's really zero point 0.3 times 40. Okay, so it's 80% of some number, 30% of 40 equals 60% of something. Well, if I call it a different something and it's not the same thing, then I'm going to have another variable. But what happens is the total amount that I have, if I have X liters here and 40 liters here, then I will have a total of X plus 40. And that's the equation that we're going to use to solve this. So 0.8x plus 0.3 times 40 is 12. And then if I distribute here, I get 0.6x plus 24. And now I subtract the 0.6x to give me 0.2x. I subtract the 12 to give me 12. And if I divide, x is 60. And be careful how many liters that is x. So in this case, the variable that we solve for is actually the answer. You have to be really careful with those, though. Sometimes you choose a variable, and the variable is not necessarily the thing that like they're questioning about. It's something that's based off of that variable. And then you can be certain that whenever you solve for x, that answer is going to be one of the answer choices. But that doesn't happen here. The x that we're solving for is the same thing as what they're asking for. So we are all good there. All right, on to number 10. So a store initially marks up a price of a product by 50%. Well, what that means is it's been increased by 50%, so that's multiplying by 1.5. During a clearance sale, the store offers a discount of 30% off the marked price. So 30% off is keeping 70% of it, so we are now multiplying by zero point 0.7. And that's they want the original price. So all that's multiplied by X, and that's going to equal the final selling price is $84. All right, so let's do this and this. So we got 150%, right? 50% markup times 70% of it, which is a 30% discount of the original is equal to the final. All right, so you can just do, 1.5 times zero point 0.7 is 1.05x equals 84. Divide each side by 1.05, and you end up with 8. All right. So again, if doing it the long way, taking 50% of something and adding into it, or taking 30% of something and subtracting it, it's the long way in one or two step problems. But in a problem like this, you really need to set it up this way. It's much more difficult, or else you'd have to take every answer and then do that. And here it's answer A, but if it were to be an answer D, it could take like a really long time. All right, so percent increase, percent decrease, looking at it in this way is definitely the way to go. All right, now on to number 11. All right, so now let's do what we did before. So P is increased by 20%. So let's be careful. And I'm not going to write it that way. Let's just talk about this. If you increase it by 20%, we've been talking about this throughout the entire lesson. That is multiplying. That is looking at it as taking 100%, increasing by 20% is 120%. That's multiplying it by 1.2. So 1.2p and is then decreased by 10%. Well, that is decreasing something by 10%. So start at 100, take away 10, and you're at 90%. So that's zero point 0.9. So you're doing 1.2p times zero point 0.9. The value of, wait, let me read that again. When the number p is increased by 20% and then decreased by 20%, the value of p is 378. What is the number of p? I think that's wording is strange. I'm just going to do it this way. I think I didn't realize it said that. It should just say the value when the number p is increased by 20% and then decreased by 10%, the value is 378. I don't know what they mean by the value of p is 378. Because if they ask what the number p is, then it would just be 3 set. I don't think that's the answer. I think they want us to find p. Okay. So we would do 1.2 times zero point 0.9 is 1.08. So 1.08p is 378. And then 378 divided by 1.08 is 350. So the answer is 350. Yeah, the wording of that is very strange. Yeah, I don't think they mean the value of P is 378. I think they want us to just find P. So yeah, I'm gonna go with that. I need to think about that more if they're because it's weird that 378 is an option. Um, yeah, I think that this is supposed to not be here because then yeah, let's just focus on the concepts here. If they want you to take a number, increase it by 20%, decrease by 10%, and the final answer is 378, your initial value would be 350, and this is how you would find it. All right. Some of these problems that I find are from a whole bunch of different places, and they're not always asked in the best way, but they're the concepts that we can take from them that you'll need to do on the SAT. That's kind of what the most important part of this is. All right. Last one, number 12. So 90 is u% less than 450. This is how I like to do these problems. I like to kind of like, don't worry about the letter u here. 90 is some percent less than 450, which means we're going to multiply 450 by some variable. Now, that variable is not going to be the answer. We're going to have to interpret that variable. Okay. That's the key to a percentage. Um, and the reason that I didn't use u over 100 like I did before is because it's u over 100 less than something. It's not u% of. If it were u% of, I would have just done what I did before and did u over 100. But since it's less than, I want to look at it a different way. I want to look at our percent increase decrease the way we've been looking at it the whole class. So what I would do is just solve for that value that I'm multiplying by. So that's 90 divided by 450, which is 0.2. And what I'm doing is I'm multiplying by 0.2. I have to be able to work backwards. So first of all, since I'm multiplying by a number less than 1, I know that it's a percent decrease. So that's why they're using the word less. And then it's how much less? Well, zero point 0.2 is 20%. Well, 20% is 80% less than 100% because again, doing nothing is 100%. And then so by multiplying by zero point 0.2, that is really an 80% discount or 80% less. So the U here must equal 80. All right. So again, just using different examples. If I said that something was a 25% discount or it was 25% less, The decimal I would multiply by is 0.75 because 25% less than 100 is 75% of it. So that's why here we're working backwards. We're saying we are getting the decimal point 0.2, and we have to work backwards this way and realize that that means 80% less. Okay. All right. That is the end. So thanks for watching and attending. Again, as always, check out our TikTok, check out our YouTube. We also offer some tutoring and we'll be having some courses coming up sometime soon. So if you need any more information about any of that, you've got the number, you've got the email. And again, thank you for coming, and I will see you next Monday for the next office hour.